Hi and welcome. I am trying to learn electrical engineering. Today the secondary cell, and after we've done it, we're going to do extensor carpi ulnaris strength training. And if you participate in the extensor carpi ulnaris strength training, which is here, das werdet ihr auch noch. Secondary cells. A primary cell converts chemical energy into electrical energy. And in a general sense, once the substances in the cells have reacted chemically, the cell is of no further use and is thrown away. Okay, we had here, I think, these dry batteries with the ammonium chloride in it and the other things, and more or less it reacts, and when it's gone, the energy. The chemical reaction of the ammonium chloride, the copper and the zinc, I don't really understand it, has made a reaction, it is done, and the battery has to be thrown away or recycled properly. Now, it is possible to recharge a primary cell, but the procedure is only partly successful and seldom worth the trouble involved. Okay, we're saying probably are they referring to this cell, and they're saying it is possible, but not that good. A secondary cell is quite differently. It is designed to store energy in this way. In charging and discharging, so under charging, an electric current is forced through the cell. Electrical energy is converted into chemical energy, which is stored in the cell. Okay, in discharging, a current is driven around an external circuit by the cell. Chemical energy is converted into electrical energy, and the cell is left empty in an energy sense. Okay, let's see. The principle of a lead acid accumulator can be shown by simply experiment. Okay, let's keep it in mind. Lead acid accumulator. Imagine someone calls the battery. It is my lead acid accumulator. Now, 2 lead plates should be immersed in dilute sulfuric acid. That is half water and half acid. Dilute sulfuric acid. I don't know what the dilute means. And we had with just in biochemistry a dilute. Sweat is a dilute out of water and salts. And I didn't mention that I don't know what a dilute is. So, 2 lead plates should be immersed in dilute sulfuric acid. Okay, we're having 2 plates out of lead and we're putting them into a mixture out of water and acid. A 2.5 volt lamp bulb connected to the 2 plates will not light. There is no energy available. Okay. You will remember that any type of simple cell must have plates of 2 dissimilar metals. We had what I was wondering about. We had carbon and we had zinc, and by the other thing we had, I think, also carbon and zinc. Okay, we need 2 different ones. Now a current should be passed through the cell by connecting a low voltage supply of about 4 volt to the lead plates for a few minutes. Okay, we're having our 2 lead plates inside our acid and water mixture, and now we are supplying them with cables to 4 volt. When this current supply is removed and the lamp bulb again connected to the plates, it will glow, showing that the cell has stored some energy while the current has been flowing through it. A car battery is an assembly of 6 lead acid secondary cells connected in series. Okay, by car battery there are 6. I think I probably is that why they are called 612 or something? Okay, there are 6 of them lead acid batteries in series. Cells in battery. You should examine carefully a car battery or laboratory accumulator and read the manufacturer's instructions for its use. I don't think anyone should just open a car battery. Okay. In a car battery are 6 lead acids in it, and now we are having the task to do it, but we're not going to do it because that is dangerous. We don't open a car battery, even if they're careful. Your investigations should produce the following informations. Let's read them instead of doing them. Number one, the electromotive force of a charged accumulator is just over 2 volt. A battery of 6, such as a car battery, has a total electromotive force of over 12 volt. Well, we are mixing some words together, I can't keep track. Is it a lead acid accumulator? But we're having dilute sulfuric acid. And we're having in it put lead plates. Okay, lead. It is a lead acid accumulator. We had put 2 lead plates into the acid, the sulfuric acid. So that is a lead acid accumulator. And we can charge it by supplying these 2 lead plates with 4 volt over some time. And that we have accumulated in the lead, the plates are lead, acid, the sulfuric acid is acid, stuff, some energy. And the car consists out of 6 lead acid secondary cells, and they're connected in a series, and each of them has 2 volts, so that whole battery of a car has 12 volt. Okay, a car battery has 12 volt. In it are 6 cells, 6 lead acid cells, and they all have a force of 2 volt. And they're all consisting out of 2 lead plates and sulfuric acid in which they are in, and the 2 lead plates are for some time put under current, and that they are charging. The storage capacity of the cell is measured in ampere hours. Okay, why not? An accumulator charged for 10 hours at half an ampere would store 5 ampere hours of energy. That makes sense. 1 ampere hour would come in if you're putting 1 ampere hour in it. If you're putting 10 hours long, a half ampere in, we have at the end of our 5/12 of day, 5 ampere in it. And strictly speaking, this is not an energy measurement unless you assume the electromotive force is constant, then the cell supplies a current. Strictly speaking, this is not an energy measurement that it has 5 ampere hours. Unless you assume the electromotive force is constant, then the cell supplies a current. This is in fact the case. A potential difference of 2 volt sending 5 ampere hours of charge through an external circuit would in fact do 36,000 joules of work. Now we're calculating some things. We are at the end of that page and at the end of our time. So we're having there 2.5 pages more to car batteries. That means if you're interested in cars, car batteries, or electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in the extended carpi ulnar strength training, then is the arm risk, and I want to say that here strongly, this is the arm risk. Now, we are having a good and stable stance all the time. The hands next to us found the fists, and we're bringing the fists down and up. The floodgate. Again down and up. Now we're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. The second rule is that we're going only as far as we can go with a little bit of effort, so we don't force anything, just as far as we go. The last time up. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. And I'm going to use no circle. You can use also a towel or something else. So you take it and on at your own risk. You press onto it with good moderate force, and then you bring the wrist down. And again up. Again down. Now same on the other side. Press again with good force and bring the wrist down. And down. Again up. And down. And the last time. And now on the outside. Press with good force and now turn the hand to the outside only as far as it goes, painless, with a little bit of effort, and not exhausted. To the inside here. And the last time in. And now change. Press again and turn to the inside. And outside. Press evenly with the whole hand, with the fourth and fifth finger. And to the outside. And the other side to the inside. And now the next exercise. Press in neutral position and bring your wrist down. And again up. And down. Last time up. And down. Okay. So now with your hand, press again evenly with the whole hand with moderate or good force. And down. And now just hold it in neutral position and press with moderate force onto the sock or towel t-shirt. And with your hand. And that was the extensor carpal ulnar strength training. I thank you very much and next time.